Hi guys, today we're going to solve a problem of hierarchical clustering. We have learned previously like what is hierarchical clustering and everything. So today we're going to solve a problem on hierarchical clustering. So we have some data points here or the data set. We call it data set. So we have the data set given in the problem. Zero point 0.07, 0.83, So here this is the data set given to us and we have to make a dendrogram tree or a hierarchical agglomeratic clustering. So you have to draw that. So first we have to start with plotting the distance and finding the distance between each point, that is between p1 and p2, p2, p3, p4, p5, p5, p4 and p6. Similarly from p1 and p3, then p1 and p4, etc, etc. So we have to draw. For that we have to draw a table. The table will look like this: p1, p2, p3, p4 and p5. Similarly you have to write the data points here also: p1, p2, p3, p4 and p5. Okay, so we'll draw this diagram like this. Okay, so we know basically we can fill this diagonal because the distance between p1 and p1 will be always 0. We know that because there is the same point, so the distance will be 0. Now you have to calculate the distance between p1 and p2. So we know a formula, Euclidean formula. So what is the formula? The formula is root over of x2 minus x1 whole square plus y2 minus y1 whole square. So this is Euclidean formula or Euclidean distance formula. Distance, right? Now we have to calculate the distance between all these points. So basically if you calculate for one of the half, either this on or this half or this half, right? Because if you calculate for this half, you automatically be calculating for the lower half, right? So if you go back and delete this, so fine, we'll calculate one of the distance, then other distances I will not be calculating. I'll put in the values, but the logic will be same. So I'll show you for one point. So one is the distance between p1 and p2. So if you see here, the distance is given p1 and p2. So here x2 is this, x1 is this, and then again y2 is this and y1 is this, right? So if you put these values in formula, so p2, what is the form for distance between p1 and p2? What is the formula? Formula, or how will you put it? Is like square root of 0.85 minus 0.07 whole square plus 0.14 minus 0.83 whole square. Okay, so if you calculate this value, we'll get the value of 1.04. okay, so this is the distance between p1, p2. Similarly we can calculate for the other values here. Just I'm writing the values. So if you write 1.04, then 0.59, 0.46, then 0.81, 0.32, 0.61, 0.77, then 0.30, 0.40, 0.35. Similarly here all the distance will be same, so if you fill it, it will be the same thing. 0.5977, 0.46, 0.61, 0.30, 0.81, 0.32, 0.40, 0.35. So I guess everybody have understood till this step. Now we have the most critical steps, so I'll use this table only. So we have to find out which is the smallest value from this table. So we can either use the top half of the or the lower half. Both of the things the same, but I'll prefer the lower half because it's easier to calculate. Okay, so on the lower half we need to find the smallest value. So what is the smallest value? If you see here, the smallest value will be 0.30. The first step is finding out the, so if you write here, after this the first step is finding the smallest value, and we need to keep on doing this, iterate it till the end. Till the end, when you'll do, you'll understand. So from here, if you see here, the smallest value is 0.30. Okay, so the distance is between P4 and P3. Okay, so we need to now you have to see which is the point that comes before, like in both of them, which points come before, right? So here we have the distance between, so if I write here, the smallest distance we have found out is P3 and P4 is the smallest, right? So here we have find the smallest. Now we need to cancel out the row and column. So how do you cancel the row and column? We have to cancel the row and column. So first we'll cancel the, so we'll cancel the row and column of the point that is smaller. So here we have find out the distance between P3 and P4, right? So the P3 comes before P4, so we'll cancel out the row of P3. So we'll cancel it out like this. Okay, P3. Okay, did you get it how we are cancelling it? This P3 and this P3 we have cancelled it out. Then we need to combine them together. This is smaller distance, so we'll be combining P3 and P4. I'll show it how you will write the table down. Okay, so now we'll, after combining it will be like this: P1, P2, P3 and P4, right? Then we have P5. Similarly here we'll write the same thing: P1, P2, P3 and P4, then P5. So again we can fill the diagonals as 0. Okay, we have filled the diagonals. Now from the table, before table, we can see P1 and P2 is 1.04, so we'll start filling it down. 1.04. Now when it comes to P3 and P4, we have cancelled out this row and this column. So P3 and P3 have cancelled out, so we'll write the next value, that is 0.46 and then 0.81. So P3 and P4, in that we'll write 0.86 and 0.81. Similarly, we'll fill the other rows. 0.61. We'll write the values of the rows and columns that we have not cancelled out. Okay. Okay, we have calculated the value. Now again from this we have to find out the smallest value. So if you check, we can find out which is the smallest value. The smallest value is next 0.32. Now can you see the distance between what? That is between P2 and P5. The smallest is now between P2 and P5. Now here P2 comes first or comes before. Yes, so P2 comes before. So what will again will do, will cancel it or cancel P2. Okay, so after cancelling, what will be, will be combining P2 and P5. So again we can write P1, then it will become P2 and P5, then P3 and P4. Similarly here P1, P2 and P5, P3 and P4. So again we can fill the diagonals. Yes, so after filling the diagonals P2 and P5, so we'll fill the values of the remaining places. So here in P2 and P5 we will fill with the remaining values. So P2 will fill the values of P5, so 0.81, and here 0.35. Then here P3 P4 will fill it as 0, same 0.46, 0.35, and P2 P5 again 0.81 and 0.46. okay, now here again we need to find out which is the smallest value. If you find out the smallest value here, we can see this is the smallest value, that is 0.35. this is between what? P3 P4 and P2 and P5. Correct? Yes or no? It is correct, right? So again we'll cancel the value which is before. So we are connecting P2 P5 and P3 and P4. Yes or no? So we will cancel P2 and P5 because it comes before P3 and P4, so we'll cancel it out. So finally what will happen here, P1, again here P1, then we'll have all the things combined. So writing is, we will write it down like this. Okay, P3 and P4 for better understanding. So again here write 0 0 and here 0.46 and 0.46. now there is only one value. If you see, you can see here, so is done, the problem is solved. We don't need to combine. So finally then P1 will be combined with P2 and P5. Now the main important thing is drawing a dendrogram. So what is a dendrogram? Everybody, we have seen some family tree. If you see family tree here, family tree will be one person will be here, then from them the one son, one daughter will come, then again they will have a husband and wife, so from them one another son will come, from here another son, so etc etc. so it will look like a family tree, but here we will draw a dendrogram. So we'll say how will we be drawing this dendrogram. So first we'll write them points, but we'll write the points between the connections. So if you finally write it down, if you see this whole thing, it will be written like this: P1, then P2, P5, P3 and P4. So finally if you combine, it will be like this. So we have to draw this as a diagram. So when you draw, what is the first two positions or places or points that we can see here? P2 and P5, right? Okay, we'll write it somewhat together. Here we can write P2 and P5, so they are combined first, so we can draw a diagram like this. Correct? The next we have P3 and P4. okay, so we can write it like this. Again we can combine them together. Now again what we are seeing here, P2 and Okay, it will be another bracket because P2 and P3 is combined before combining with P1, right? So again it will be combined like this, right? Then finally you have P1. So P1 will be going and connecting with this. So your dendrogram should be looking like this. So 1 2 5 3 and 4. So this is your dendrogram. So for full marks you should be doing all this calculation, and finally you will be able to draw this dendrogram. This is what a dendrogram is called. Okay, so that is what is the calculation of hierarchical clustering, and that's how you draw a dendrogram. Thank you.